Here's an example of a problem where we calculate the speed of a wave, wavelength, and period. So the first thing we're going to do is use some distance and time information to calculate speed of a wave. And in this case, they're giving us a sound wave. Sound travels at a speed that, of course, depends on the medium. So it is going through the air and depends on the humidity and the temperature, but they give us information to calculate that. But if you pay careful attention here, the hiker, I have a stick figure, shouting, and they give us the distance that the cliff is away from the hiker, but they give us the time that it takes for the sound to really travel like a round trip, because the hiker shouts and then they hear the echo 2.75 seconds later. So by then, the sound wave has traveled twice that distance, right? So let's write down our givens. We have our distance, delta D, that's a really old variable. We have 465 meters times 2, right? So if I do that math really quickly, hopefully you have your calculator out. If not, maybe pause and go get it. But that comes out to be 930 with 3 sig figs meters. And then we have time is 2.75 seconds. So then I can calculate the speed of sound is just going to be distance over time. It is a constant speed. We just need to know what it is. So I've got 930 over my 2.75 seconds. Okay, so plug that into your calculator and round it to 2 sig figs, and I get 338 meters per second. Okay. Now I've done so many of these problems that I know that that's about right for the speed of sound. It's a really big number, okay? Of course, but you still sometimes hear the delay, the echo, when you're far away from something. Now, they give us wavelength in the next problem. And so remember that the variable for wavelength is a Greek letter, lambda. It looks kind of like a wave, at least this part does. So that's 0.750. That's actually the dependent variable. So we're kind of going backwards. We know the speed, we just solved for that. And we're trying to use those two to find frequency. So then the formula that I have written down is this one. So I'm going to use my information and then solve for frequency. So that means I need to multiply by both sides, right? So that moves that, but then I'm going to have to, I'm running out of space, divide both sides by 0.75 in order to get frequency by itself. And that way I get meters to cancel, and I'm left with the units I want, which is, notice, it's like 1 over seconds, or waves per second, which is also known as hertz. So if I do that, when I round as I go, I get 451 hertz. Okay. But it's also okay to write this as 451 waves per second, or 1 over seconds. That's supposed to be an S, not a 5. Okay. And then the period of the wave, we know that is capital T, right? And that the formula is the reciprocal of the frequency. So all I have to do is do 1 over 451. And remembering that, like I said, this is waves per second, or 1 over second. So the reciprocal of the reciprocal, okay, I'm going to get a very small number. But I'm supposed to keep 3 sig figs, right? So the leading zeros don't count. So I need to go 0.00. So far I have no sig figs. 2, 2, and I think I have to round it to 222. And then units per period are always in seconds. Okay, that means that between every wave crest, I only measure this short amount of time. Okay, I'm going to pause and go on to, I need to paste the next slide in. This next problem is asking us to calculate speed. Wave speed is really what they're asking for. Okay, and what do they give us though? This is kind of confusing, this part. Oops. So when they say 5 pulses are generated every 0.1 seconds, what they're trying to tell us is give us enough information to calculate the period. So let's do that. So, or the frequency, since we have frequency in our formula, maybe let's write it like that. So frequency is always given as waves per second, right? And they're actually giving us 5 waves or 5 pulses. So let's write that 5 waves every 0.1 seconds. So whenever you see how many waves you want to put, if you're trying to get frequency, you always need to put time in the denominator, right? Okay, because then you're going to get hertz, which is the units for frequency. If you wanted period, you would need to flip this over and put seconds up on top and divide by 5 to get how much time a single wave takes, because that's the definition of period, the time for one cycle or one wave. Okay, but since frequency is in our formula, let's just stick with this. So then we would say if 5 waves takes 0.1 seconds, then, oh, I could have done this in my head, sorry. Then I can calculate that I can get 50 waves in 1 full second, okay? And let's see, oops, I gotta watch sig figs here. The 5 is infinite as far as sig figs go, and then they gave me 3 sig figs in the time, so I need to keep 3 sig figs there. And then they gave me wavelength, so lambda is 1.2 centimeters, but that's not very nice. I like to have that in meters. So let's move the decimal back 2 places. Okay, so 0.0120 meters. And I am looking for speed, or V. So then I've got my formula, still the same. And this time I'm solving for V. So 0.0120. And then hertz, but it's probably better units wise to put 1 over seconds. Again, my S doesn't look too good. Okay, so then if I'm trying to get V, I'm just multiplying both sides by 50. Okay, so then when I do that, I get 0.6 on my calculator, but I do need to add some zeros to make it have 3 sig figs. And then when I multiply m times 1 over s, I get meters per second, which is good. That seems like a good unit for speed. Okay. there I'm done. So thanks for watching.